In Chapter 6, we're looking at something called two-way tables. A two-way table, it says, organizes data about two categorical variables. So when we have two quantitative variables, then we can make scatter plots and talk about regression and stuff like that. But when we're talking about categorical variables, scatter plots don't really work as well. We had a couple of homework problems that asked you to kind of try to create one in terms of categoricals, but then we just end up with rows of points. So instead of trying to do that, especially if we have two categorical variables, there wouldn't really be any way to put those onto a scatter. So what we do is we create a table that organizes this data. So on page 150, there is a table that we'll look at, and I'll write it out here. Maybe.
Close. Close.
You want us to write this down?
You can, or it's in your book, so you can just kind of reference it there too. It's on page 150 in the book.
Do you think it'd be easier if we had it written down here?
Depends on your note-taking style.
Yep.
Oh.
Yeah, I should probably take notes. So
For me, my note-taking style varied depending on what kind of class it was. Sometimes I did better just listening and watching, and sometimes I needed to like write everything down.
yeah, I always do really bad on tests when I try to adopt other people. Some people are like, "Oh, I don't even study for this test." I'm like, okay.
Most of the time I just listen.
You don't even study.
I
What's that
overstudy
last box at the top?
for
What is it?
everything. I overstudy.
Total?
Oh, total.
All right, so our categorical variables here are age. Age is something that can either really go numerical or categorical, quantitative or categorical. We could say it's quantitative, but often what we do is kind of create groups of ages and call those categories. So by grouping together ages 15 to 17, that's now a category. So we have categories of ages, and then we have the category of gender. In this data, it says our college students in 2003, and it's in thousands of persons. So then we could just kind of look at this data for what we see and what we might expect. We would probably expect the majority of college students to be in the 18 to 24 range. That's what we call like a typical college student. Okay? There's some kids who graduate early, so they might start college at 17. There's some who might graduate a couple of years early, and so then we end up with some 15. It's rare that we get somebody under 15 in college, but it happens. Those numbers are pretty small. There's not a lot of students who start college before age 18. 18 to 24 is where we're going to have the bulk of it in. 25 to 34 might be students who like kind of started college at a normal age, but were maybe just going part-time because they couldn't afford to be a full-time student. They needed to work some. So we're still going to expect a kind of decent amount in that category. And then age 35 and up is probably students who are going back to college, maybe didn't have the opportunity to ever go, and so now they're starting back again.
Do you have your master's?
I have a master's, yeah. This is undergrad information though.
Oh, that's
And this would be for undergrad, yeah. This is just strictly undergrad information, so it would be people going for a master's or something like that.
Or masters.
So, what we see then is the individual pieces of information. So I could ask you, what is one particular piece of this data? So I could say, how many male students aged 25 to 34 were enrolled in college?
1589.
Okay, 1,589, and this is 1,000, so then we would add really 3 more zeros to the end of that. And then we total up down the column, so I could say, how many total female students were there enrolled?
Why would we add 3 zeros?
The top of the table, which I didn't write out, the heading of the table says college students by sex and age in 2003 in thousands of persons. So how many total female students were there enrolled?
89. In what? In wait.
9321.
9,321 is our data point there under the total female.
I was looking at total and female.
So then going across our row, these totals over here are how many per age group. So how many total 15 to 17-year-olds were there? 150. Okay.
Okay, now I get it.
So then this chart represents that bottom corner, 16,639, and then really plus 3 more zeros at the end of that, total students enrolled in college in 2030. Okay?
16.
So it would be 16 million.
Yes.
Wow.
Yep.
So it's 150.
Yes.
But
Yes, like,
Everywhere.
but this is, yes, colleges. This is not like a college. This is,
So would would a sophomore in high school taking a dual enroll, that would count?
Yeah, we're doing all
you know, I guess so, because you are enrolled in the college. So that's how we're getting some in that 15 to 17 category, some dual enrollment.
Wait, are we going to be referring to this chart later, like in our?
Yes.
Okay.
So then, one way that we can analyze what we see in this chart is to create what are called marginal distributions. The marginal distributions, we're looking at taking one particular type. So if we look at just one particular category, so the distributions of gender alone or age alone are called the marginal distributions. The reason why we call them this is because they appear in the margins. So our marginal distributions are the stuff that we find in the margins of the chart. Okay.
That's all that means.
When we talk about the marginal distributions, we're talking about the distributions or the spread or the data for the individual categories. So we can use those to then answer some questions about the data, like what percent of college students are 18 to 24. Okay, so how would we find a percent that are 18 to 24? First, we would need to know how many of them are 18 to 24, which would be
10,
3, 6,
3, 6, 5, 0, 0, 0.
out of, when we're talking about a percent, we're looking at out of the total everything. So 16, 639. We could do that division out on a calculator, and it's going to give us 0.623. And since it said percent, we're going to bring that decimal up twice. So 62.3% of students enrolled in colleges are what we would call traditional college students. Okay. We could do that same thing for each and every one of the categories. So we did just the one particular group of 18 to 24, but we could also do it for 15 to 17, 25 to 34, and 35 and up. And what would you expect about all of those percentages then? Together.
It'll equal 100%.
It should all equal 100% because that should cover all college students. I guess. I mean, they really kind of left a little bit of a hole in here. What if somebody was under 14? But maybe nobody was in 2003. You know, so I guess we're assuming that this really does cover total student enrollment. Then all of those percent should add up to 100. Okay. We could then say what percent are female?
Well, 9,321 divided by 16,639.
Nice.
Okay, we can work that out on a calculator, and I have no idea what that is because the book didn't do this example.
And look.
And so we get 56%. Without doing any calculation, what percent are male?
100 minus 6.
100 minus 56, so 44, right? Because students are either male or female. Okay, so that should cover everything.
Where did you go?
Well, you know, nowadays.
Yeah, we're going to say students are male or female.
Wait, where is 100 minus 56?
I said once we know what percent are female, it's easy to answer the question what percent are male because they have to be one or the other. So 100% minus 56% would leave 44% to be male.
Okay.
Because just like all the ages should add up to 100%, the gender should add up to 100% as well. For conditional distributions, okay, the conditional distribution is the percentages of each entry in a column of the whole column. So then we're not looking at like an individual categorical total over the whole table total. We're looking at a middle of the table data entry divided by an individual total data entry.
So like 89 divided by 93.21.
Yes. Okay. So I'm gonna erase some of this blue stuff around here to get room to do this other stuff. So with marginal, we're looking at the margins to do our division. So we're taking like a total divided by the total. When we talk about conditionals, we're going to be taking an individual data entry divided by an individual total, not the grand total. Okay. So our questions for this would look something like this. If we know a student is 18 to 24. Let's see. They started this question weird. Let's see where this question goes.
I don't. Oh no.
That was so fun. If then statements. I loved that. They
That one
were.
Bible
That
verse
was
was so
probably
hard,
marking.
though.
That was my favorite
That one
one.
Bible verse
That
was so hard. Remember that?
I
What's that
actually,
one
I think
verse?
I
Yeah,
got that
I know.
all right. Because I loved those. I
It was on
just
the
loved
homework.
it. Like the little signs and like kind of, yeah.
Okay, so then
You got
if
it.
we know a student is 18 to 24, then what is the gender distribution? So what percent are male and female, but just within that particular category? So if we know they're 18 to 24, we are only talking about that information. Nothing else in the chart is important to us.
So would you add?
Okay? So then what percent would be female? How would I find that?
5668 divided by 10365.
Mhm.
And it's
And then we could do that division on out. Turns out to be 54.7, and then male would be the other side of that, 45.3. Okay, so in a conditional, we're giving a condition to it. So we talked about conditional phrases in the other half of this class for those of you that took that, and so we're adding an if here. If we already know that they're 18 to 24, we're reducing down the amount of data that we're concerned with. We don't care about any of the rest of the data. Okay. Alright, so then example 6.4, and I'm not going to go through all the calculations on it, but it's on page 154 in your book, says a question that some admissions people might be concerned with is the percent of men and women at different ages as we look at students. So we could find each of those conditionals. So we just found the conditionals for the 18 to 24. We could find the conditionals for the other groups as well. So for 15 to 17, it turns out to be 59% female. Then in 18 to 24, it's 54.7. In 25 to 34, we get 54.5. And then in the 35 and up, it's 63.1% are female. So what would that tell us as an admissions person when we look at those numbers? Well, it looks like more females are doing dual enrollment because that was a higher percent there. Then as we go into the 18 to 24, 54% to 45%, that's a pretty even spread. Gender is not really 50-50. I mean, every baby when being created has a 50-50 chance, right? But on the whole, population isn't always going to be 50-50. So, but 50, 55, 45 ends up pretty close for the main bulks of college enrollment between age 18 and 34. But then once we jump up to 35 and up, those students are choosing to go back to school at an older age. Females are 63%. So it looks like more women are either putting off school for some reason or going back again if they didn't complete it.
Children probably. Like having kids and maybe
Mhm.
we'll
Stress levels
go
are
back.
way higher too.
Plus, like Christian Ed's expensive, so
Yeah.
pay it off. Same things,
The next example in the book, 6.5, says, what is the distribution of age among female college students? What is the distribution of age among female college students? So when we're talking about conditionals, we want to narrow this down. What are we narrowing this down to?
Females.
Females. We know they're female. We want to know about their ages. So then we're just going to be looking at this column. And we could take 89% divided by 9,321. 5668 divided by 9321. And we can find out what percent of the females fall into each of those groups.
And that's traditional kind, right?
That's the conditional. Because it's taking data entries from the inside of the chart and comparing them to the totals. On the marginal, we're only looking at totals compared to totals. Okay? And that is the end of our notes for today.